The match control flow operator. Rust has an extremely powerful control flow operator called match that allows you to compare a value against a series of patterns and then execute code based on which pattern matches. Patterns can be made of literal values, variable names, wildcards, and many other things. Chapter 18 covers all the different kinds of patterns and what they do. I hope Argyle is in there. The power of match comes from the expressiveness of the patterns and the fact that the compiler confirms that all possible cases are handled. Think of a match expression as being like a coin sorting machine. Coins slide down a track with variously sized holes along it, and each coin falls through the first hole it encounters that it fits into. In the same way, values go through each pattern in a match, and at the first pattern the value fits, the value falls into the associated code block to be used during execution. Because we just mentioned coins, let's use them as an example using match. We can write a function that can take an unknown United States coin and, in a similar way as the counting machine, determine which coin it is and return its value in cents. So we have here an enum creates the type coin with 4 variants: penny, nickel, dime, quarter. And we have a function value in cents with 1 parameter, which is an instance of the enum coin, and it returns a U8 value. And then this function has a match expression. So we match coin, and then if coin is a penny, we do this. Coin is a nickel, that. Coin is a dime, that. Coin is a quarter, that. We have exhausted all the possibilities because they came from this enum. Let's break down the match in the... I should read these first because they're about to say the same thing I just said. Let's break down the match in the value in cents function. First, we list the match keyword followed by an expression, which in this case is the value coin. The match keyword followed by an expression. So this whole thing is an expression, I think, and this is an expression. This seems very similar to an expression used with if, but there's a big difference. With if, the expression needs to return a Boolean value, but here it can be any type. The type of coin in this example is the coin enum that we defined on line 8. Next are the match arms. An arm has 2 parts, a pattern and some code. The first arm here has a pattern that is the value coin, a penny coin. When I see these I'll try to read it backwards. It has the value penny coin, and then the fat arrow operator that separates the pattern and the code to run. The code in this case is just the value 1. Each arm is separated from the next with a comma. When the match expression executes, it compares the resulting value against the pattern of each arm in order. If a pattern matches the value, the code associated with the pattern is executed. If that pattern doesn't match the value, execution continues to the next arm, much as in a coin sorting machine. We can have as many arms as we need. In listing 6.3, our match has 4 arms. 2, 3, 4. And that's because we're matching against an enum, which has 4 variants. The code associated with each arm is an expression, and the resulting value of the expression in the matching arm is the value that gets returned for the entire match expression. Curly brackets typically aren't used if the match arm code is short, like if it just returns a value. But if you want to run multiple lines of code in a match arm, you can use curly brackets. For example, the following code would print Lucky Penny every time the method was called with a coin penny every time the method was called with a penny coin, but would still return the last value of the block 1. Yeah, okay. So right, I've got in my main function here println brackets placeholder please help. What can I call this? I need a word for this symbol. Okay, so value in cents penny coin. And if you see here, I decided to try out the print macro instead of the print line macro. Because if I use print line here, then so first, okay, function main says print line this, and then it goes and gets it. So that's this, and you see I have a new line here, and that's why it skips. Let me go ahead and take that out so you can see what I'm talking about. So this is the result that I had the first time, which was print line to Lucky Penny and then print line to 1, and I thought that is not, I don't like it. So started playing with new lines and using the print macro instead of print line, because I figure I know what print line does, so perhaps print does it without a new line, and it seems to be the case. So I have, it might seem strange that I have print line here, right? But then I have print here, and then I'm adding a new line anyway. But for print line, you get the argument is printed, and then it calls a new line. So print line means there's going to be a new line after. And the way for me to get a new line before was to say print and then add in the new line. And I know I just changed that to new line, but I forget what it did. It must have been this. Yeah, let me see it again. So here is if I use the print line and then with the new line. Right. So this print line, it creates a new line after this runs. So it's prints Lucky Penny and then new line. So I also have a gap here because I called for it. But I want this to be on the same line. So oops. Yeah, okay. Down here, I'll do it one more. Whoops. Oh. Okay. Where was I? Patterns that bind to values. Yeah. Another useful feature of match arms is that they can bind to the parts of the values that match the pattern. This is how we can extract values out of enum variants. As an example, let's change one of our enum variants to hold data inside it. From 1999 through 2008, the United States minted quarters with different designs for each of the 50 states on one side. No other coins got state designs, so only quarters have this extra value. We can add this information to our enum, by changing the quarter variant to include a US state value stored inside it. Let's imagine that a friend of ours is trying to collect all 50 state quarters. While we sort our loose change by coin type, we'll also call out the name of the state associated with each quarter, so if it's one our friend doesn't have, he can add it to his collection, or she can add it to her collection. In the match expression for this code, we add a variable called state to the pattern that matches values of the variant quarter coin. When a quarter coin matches, the state variable will bind to the value of that quarter state. Then we can use state in the code for that arm like so. If we were to call value in cents Alaska US state quarter coin, coin would be Alaska US state quarter coin. When we compare that value with each of the match arms, none of them match until we reach state quarter coin. At that point, the binding for state will be the value Alaska US state. We can then use that binding in the print line expression, thus getting the inner state value out of the coin enum variant for the quarter. So I have here derive debug. Oh, are they going to tell me I need this? They told me I needed it here. I have derive debug for enum US state, and I included some states, and then derive debug for, I made another enum for the nickel. It's called back, and the variants are garbage, recycling, and compost. And then here we have the enum for coin, but I just did all this earlier, so I made it a slightly different name than our previous enum for coin. So in this enum we have penny, that doesn't have any data associated with it, and then we have nickel that has data associated as a variant of the enum back, and then dime has data associated to it with the variant of the enum US state. So I've decided to add a state of pure imagination for the dime, and then the quarter has data associated with it of type variant of US state. So we have derive debug for US state, and then derive debug for back. We don't need it for coin, and that would be because down here we're using the derive debug. There's a word that starts with an S that they used. It's not symbol, it's something for this. Okay, so we don't have any of that unless back or state is involved, right? So I've got this main function ready to go. So open up my little terminal and cargo run. Yes, state quarter from Canada. Did I put Canada in there? Okay. Let's change it to Colorado. California. I'll just leave it. Now, we can say, in println, we can say Canada US state quarter coin big S. I can change this to, let's say, I'll just change the US state part from Canada to Alabama. 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 It's too late to change it now. Alabama. And of course it's gonna do exactly what it's supposed to, right? Yes, there we go. Okay, so then we can say going to change this to dime. Yeah, why not? So dime, but for that, I'm going to use my state of pure imagination. Down here, cargo run, state dime from pure imagination, 10. And last but not least, we will say a nickel, okay? And now instead of US state, we need a variant. Ah, yes, I see this. We need a variant of the enum back, and we will go with let's go with recycling. Okay. And then running it, we have look at this photograph of recycling 5. Very good. I read this. Yeah, we're sorting, and then do you know what happens if you take a nickel? No, if you take a Nickelback CD and you put it on a train track and you let the train come and run over it, it's really cool. What happens is it still sucks. In the match expression for this code, we add the variable state. Yes, I read that. Okay. If we were to call this right. So what we have going on here is value and sense is instituting this, what I've been calling a parameter variable, and then it's gonna use it for each match on each match arm, and then because 3 of the variants of the enum coins have data associated with them. I see that VS Code has made them different colors for me. I appreciate that. Excuse me. It looks like we can just instantiate a variable, no, a parameter variable for each of these as well, which is consistent because we have them in the, I guess, the empty tuple, or inside of a tuple notation. And then that is, yeah, and then that is how we refer to it here. And so that's one of the reasons that I wanted to do more than just say state, because even though, you know, obviously the US state enum is not the same word as state, but really this could be pickle. Like, we could change for one of these, could do it here. Oops. This is what happens when I type ICW instead of, I did it again, CIW. Pickle. And then I just have to change it down here as well. CIW. Pickle. Okay. And then, it works. Let's go ahead and change this to coin, dime, US state, and then, oops. And then, which one? How about Alaska? Okay. So state dime from Alaska. Right. Matching with option T. In the previous section, we wanted to get the inner T value out of the sum case when using option T. We can also handle option T using match, as we did with the coin enum. Instead of comparing coins, we'll compare the variance of option T, but the way that the match expression works remains the same. Let's say we want to write a function that takes option I32, and if there's a value inside, adds 1 to that value. If there isn't a value inside, the function should return the none value and not attempt to perform any operations. This function is very easy to write thanks to match, and it'll look like this. We have the function called +1 with the parameter variable x, which has to be an option I32, and the result is an option I32. And in the function we have a match statement. We match x to none. If it matches none, then we result none. So this result is an instance of the option I32 enum, and it's the none variant. And then we try to match some value. See, I just started reading there. Okay, so then x, if it isn't none, it moves on to match against some, and if it is some, then we have a parameter variable which they called I, and I have called int, just because I want to make sure that I keep in mind that they are creating these parameter variables and naming them what they want. So like x could be pickle. I mean, it's gonna be, in fact. So here we go. Did I already use pickle? Yeah, I might have, but who cares, because that was surely in a different scope. Right. So now, named it pickle, and it works just the same. And this, instead of int, this could be something completely different. So let's examine the first execution of +1 in more detail. When we call +1 5, the variable pickle in the body of +1 will have the value sum 5. Oh, here it is. Yes. When we use 5 as the argument for +1, where's my main? Okay, so here we are. Wait. Oh, here it is. Yes, +1 with 5 as an argument. Okay. So the value of this is sum 5. We then compare that against each match arm. So it's not none. Move along. Then the sum 5 value. That's what. Okay, right. Then sum 5 matches some parameter variable. Does sum 5 match sum I? Why, yes, it does. We have the same variant. The I binds to the value contained in sum, so I takes the value of 5. So over here I've said, just to be clear, I don't know if it's more clear, but int. So sum int binds to the value of 5. So this is 5, right? The code in the match arm is then executed, so we add 1 to the value of I, or int, and create a new sum value with our total 6 inside. So our sum int goes in, and the result is a sum, S-O-M-E, variant with the value of int +1, which makes 6. Right. Now let's consider the second call of +1, where x is none. We enter the match and compare to the first arm. So the second call is here. Right. So +1, and we're taking in none. So +1 says, okay, my pickle is none, so let's match my pickle. And then it comes to the first arm and says, well, there it is, none. And then we return none. Yep. it matches. There's no value to add to, so the program stops and returns the none value on the right side of the match arm expression. Because the first arm matched, no other arms are compared. Combining match and enums is useful in many situations. You will see this pattern a lot in Rust code. Match against an enum, bind a variable to the data inside, and then execute code based on it. It's a bit tricky at first, but once you get used to it, you'll wish you had it in all languages. It's consistently a user favorite. Matches are exhaustive. There's one other aspect of match we need to discuss. Consider this version of our +1 function that has a bug and won't compile. Here I've called it +2 just because I didn't want to have to comment out my other +1. So I have function +2, and it takes in, well, it's real similar, right? So here's +1, and we have a match statement, and then it's got none and some, right? But here match x has only one arm. When we try to compile it, it will not compile, and it gives us the error on line 95, match x, pattern none not covered. Rust knows that we didn't cover every possible case and even knows which pattern we forgot. Matches in Rust are exhaustive. We must exhaust every last possibility in order for the code to be valid. Especially in the case of option T, when Rust prevents us from forgetting to explicitly handle the none case. It protects us from assuming that we have a value when we might have null, thus making the billion-dollar mistake discussed earlier. So I can fix this. We can fix it. All I have to do is add this line, none, none, no, and then we're good to go. Yes. Wait. Oh, I didn't change it here. Good thing I made it say +2. Okay, so we'll come in here and say, oh, okay, I can do better than that. We'll say 2, and then 2. Yes, some 5, some 7, and none. Who cares? So, one thing that they said here, matches in Rust are exhaustive. Matches are exhaustive. So the way this match statement is exhaustive is that we're using the option enum, and the option enum can only have two variants. It can have a some variant, or it can have a none variant. I guess that might be wrong, but it seems reasonable. I think it's the case. And here we have a match with 4 arms because the enum we're matching to, which is coins, has 4 variants. So introducing us to enums and match statements back to back is a really great idea. But then, of course, I said match statements, didn't I? Match expressions. But, oh, I just hit, did it do anything? It did. What did I hit? Anyway, but matching can match any pattern. It doesn't have to be an enum. And its variants, So they will now tell us how to use matches freely and account for... Okay, that's weird. Oh, it's the bottom of the page. Okay. The placeholder. The underscore placeholder. Rust also has a pattern we can use when we don't want to list all possible values. For example, a U8 can have valid values of 0 all the way up to 255. If we only care about the values 1, 3, 5, and 7, we don't want to have to list out 0, 2, 4, 6, 8, 9, and then all the way up to 255. Fortunately, we don't have to. We can use the special pattern underscore as a placeholder instead. Right, so in this instance, matching to some U8 value, we most certainly do not want to try to use an enum because we don't want to have to list every possible variant of a U8 value, but you could. So let's see, I'll go ahead and take out these things, and then let's call this function side B, and then this can be, okay, this will be new fn main, and do that. Oh, that wasn't it. That and that. The pattern underscore will match any value. By putting it after our other arms, the underscore will match all the possible cases that aren't specified before it. The empty tuple is just the unit value, so nothing will happen in the placeholder case. As a result, we can say that we want to do nothing for all the possible values that we don't list before the placeholder. Let me read that again. As a result, we can say that we want to do nothing for all possible values that we don't list before the placeholder. Okay? Let's run it. Didn't look to see if it is supposed to have... Yeah, okay. Need to tell it to... Oh, hi there. How many of you are there? I got lazy. Okay, so let some U8 value equal 0 U8. Match some U8 value. If it's 1, oh. Look, but is not any of those, so didn't print anything. Let's see what we got. If it's 1, if it's, let's try 2. What do you know about 2? Not a lot. Okay. We know about 3. Got a match arm for 3. Tree, yes. 5 is shoe, and 7 is bam. Okay. Bam. But the match expression can be a bit wordy in a situation in which we care about only one of the cases. For this situation, Rust provides if let.